In this lesson, we're going to look at angles of rotation and measuring those in radians. We'll come back to our trig functions in our next lesson, but today we're going to focus strictly on angles of rotation. In the diagram on your screen, there is an angle of rotation drawn. Its starting side, our initial side, is on the x-axis. Its endpoint is at the origin, and then the other end or side of the angle is what we call its terminal side. We also draw an arrow to show which direction forms the angle, because I could have easily drawn the arrow to go the opposite direction, and that's a totally different value. So let me draw that in there. If I drawn the arrow this way, okay, that gives me a different measurement than if I draw it this way. So we need that arrow to tell us which direction is the angle of rotation. Looking at those two angles, so let's start with the red angle. You can certainly see that it's going to be more than 90 degrees, but it's going to be less than 180 degrees. But what about the blue angle that I drew with the arrow? It's going to be larger than 180 degrees. And so in trigonometry, angles can have measures greater than 180 degrees. They can have angles more than 360 degrees. They can be even less. They can be a negative measure. So I could have a negative 10 degrees. All right, let's look at another diagram. And I am looking on page 825 of your work text. If the angle of rotation is less than 1 revolution in the counterclockwise direction, so this is counterclockwise direction, you get a positive degree. Okay. If it measures clockwise, so in that case this direction with the blue line, notice you get a negative 103 degrees. So counterclockwise is positive, clockwise is negative. We also have an important word called coterminal angles. Coterminal angles are angles that share the same terminal side. So here is the terminal side for both angles, and so the two angles together would be considered coterminal angles. In our third diagram here, because you can have any number of revolutions with an angle of rotation. So for instance here, I do one, let me grab my pen here. I have one complete revolution and then a little bit more. Or I could actually have, there's one revolution, there's two revolution, there's three revolution, and let's say I stop here. Okay, so because we can have multiple revolutions for an angle of rotation, we can have an angle with any positive real number. And if we go counterclockwise, then our angle of rotation is going to be any negative real number. Okay, at the top of the next page, it asks us to draw an angle of rotation of 310 degrees. And then it asks in what quadrant is the terminal side of the angle. Let's start by labeling our coordinate plane here. This is going to be our 0 degrees. Going counterclockwise, we have 90 degrees. Counterclockwise some more, that is 180 degrees. And this is 270 degrees. And then eventually we're back to 0, or 360. So if I want an angle of 310, well, that's definitely more than 270. So how much more than 270? Well, let's see, that's be 270 plus about, 40 degrees more. So it's a little bit less than a 45 degree angle. So that would be about right there. So which quadrant is that in? Keep in mind, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And yes, you need to know those quadrants. So this one is in quadrant 4. All right, moving down the page. On the next graph, using the graph from the previous step, we want to draw a positive coterminal angle. So let me add in the one we had just before this. which was right there. And now we need to add a positive coterminal angle. Okay, coterminal meaning both angles are going to have the same terminal side. So what I'm highlighting here in blue, that is the terminal side. And we want a positive angle, so that means we're going to go counterclockwise. So rather than just going around once, let's go around twice, and boom. There is a positive coterminal angle. Maybe I should draw in the first one. The first one started at 0 and went that direction. And on part C, it says from the same graph of the previous two steps, draw a negative coterminal angle. Now I'm just going to draw that on this previous graph here. So a negative coterminal angle would be going in the clockwise direction, and that would be right there. All right, up to this point, we have been measuring our angles in degrees, and that is what you're very familiar with from elementary and middle school. Well, there's another measure that we use, and that is called radians. So if I take a circle here, and I'll make the radius equal to 1, so just a unit of 1 radian, and the circumference then of the entire circle is 2 pi r. If I substitute in 1 for the radius, then my circumference is 2 pi. So the distance all the way around the circle would be 2 pi. Well, what about halfway around the circle? Well, halfway around would just be pi, right? And what's half of pi? Well, that would be pi over 2. And between pi and 2 pi, well, that's 1.5 pi, or we could call it 3/2 pi. So I'm hoping you notice that we're kind of seeing a different measure here in radians, and that we know that 360 degrees is equal to 2 pi radians, which gives us a conversion, if I simplify that, is to 180 degrees over pi. And this is a way that we can convert between degrees and radians. So let's look at some examples of converting between degree measure and radian measure. And we're going to do more radians in class tomorrow. So if you're converting degrees to radians, okay, you're going to multiply by pi over 180. If you want to convert radians to degrees, it'll be 180 over pi. So let's look at the table here, and let's see if we can convert some of these measurements. So if we have a radian measurement of pi over 8, okay, the pi itself kind of gives you a clue that it's in radian measure. So we're going to take that pi over 8 and multiply by 180 over pi. Okay. Now the pi's do simplify to give us 1, and we get 180 over 8, which simplifies to 22.5 degrees. All right, let's try another one. 4/3 pi. Well, let's multiply by 180 over pi. Now you'll know if your conversion factor is set up correctly, because the pi's will simplify out, and then you can simplify the 180 times 4 divided by 3, which is 240 degrees. So let me show how you can check to see if you have this set up correctly. So let's say I have 9 pi over 2, and I multiply it by pi over 180 accidentally. Okay, so we don't want to do this. Notice that the pi's are not going to cancel. I'm going to get 9 pi squared here. All right, that's a clue that I've set my conversion factor up incorrectly. So let's see if I can erase that and set it up correctly as 180 over pi. In this case, my pi's do simplify, and I get 810 degrees. All right, negative radian measures work the exact same way. You just happen to have a negative 7 pi over 12 times 180 over pi. My pi's simplify out, so I know I have it set up correctly, only now I'm going to get a negative 105 degrees. I'm going to leave that last one for you to work out yourself and check yourself with the quiz. All right, turning to the bottom of page 829. On your turn, we're going to convert each of these measures from their starting measure into the opposite. So we're going to start with negative 495 degrees. All right, since we're starting with degrees, that means degrees has to go in the opposite location. So that means we're going to put it in the denominator, 180 degrees. And in the numerator, I'm going to put pi. Now, don't put 3.14 in for pi, just leave it as pi. So in your calculator, you would simply put negative 495 divided by 180, and you will get a negative. In this case, we always want a fraction. So we're going to get a negative 11 over 4 pi. So just leave that pi as pi. On number 9, 13 pi over 12. Let's convert that. Since I'm starting with radians, because I have a pi there, pi goes in the denominator, 180 degrees in the numerator. The pi's will simplify out, and I can put 13 times 180 divided by 12 in my calculator, and I will get 195 degrees. All right, last thing I want to do is introduce to you what we call the unit circle. Unit because the radius is 1 unit. And of course, it's a circle. The angles of rotation that are shown in this unit circle are rotations or angles that are commonly used in trigonometry, with the radian measures outside the circle and the degree measures inside the circle. So let's see if we can fill some of these in. So let's start with the degrees. Okay, so we know starting here we have 0 degrees and we have 30 degrees. Well, halfway, I know 90 is up here, I can go ahead and fit in 90. So halfway between 0 and 90 is 45 degrees. Continuing around, I'm going to go here and put 180. So from 90, I have 120. And then halfway between 90 and 180 is 135 degree. And 150, 180. And then I come down to 210. And here I have 225 degrees. And then 240. And then 270 degrees. And then 300 and 315 degrees. Okay, so what you can see here is you have 45. Here is 45 from 90. Here is 45 from 180. And here is 45 from 370. Now the other angles here, we have 30 degrees and here's 60 degrees. Here we have another 30 degrees from 90. Here's a 60 degrees from 90. Here's 30 degrees from 180, 60 degrees from 180. And then here, 30 degrees from 270 and 60 degrees from 270. Now see if you can fill in all the radian measures on the outside. I'll help you get started. The 30 degree is pi over 6. See how many more you can fill in. And we're going to talk more about the unit circle tomorrow. And in case you're wondering, yes, you will have to have this memorized.